Hello friends, welcome to my new data structures and algorithm in Java tutorial series video. Friends, in this tutorial we will discuss the adjacency matrix implementation of an undirected graph. So friends, in our previous tutorial we discussed what is an adjacency matrix and how we can represent an undirected graph into it. So friends, in this tutorial we will see how we can implement an adjacency matrix to represent an undirected graph through a demonstration. So friends, let's suppose we are given an undirected graph with 4 vertices as 0, 1, 2, 3, where 0 and 1 are connected through an edge, 1 and 2 are connected through an edge, 3 and 2 are connected through an edge, and 0 and 3 are connected through an edge. So friends, using this code here, we can actually represent this undirected graph into a form of matrix. So let's see this demonstration step by step. So in our previous tutorial we discussed that using a matrix we can represent a graph. So here in our Java class graph we are having this adjacency matrix, and in the constructor we are initializing this adjacency matrix with the number of nodes in the graph. There is a method addEdge which takes two parameters, let's say u and v. So here suppose if we want to add an edge between 0 and 1, so 0 would be u and 1 would be v. So through this code we can add an edge between u and v. So we'll see its demonstration step by step. So let's suppose in our main method first we initialize the graph with the number of nodes. So here you can see there are 4 nodes. So we are passing the number as 4 here. So now the execution step goes into the constructor of graph where nodes is having value of 4. So in the constructor we simply initialize an object of matrix by providing the value of row and column as the value in the nodes, which is nothing but 4. So after execution of this step it will create a two-dimensional array which is nothing but a 4x4 matrix. So it would look something like this. So here it will be represented as an adjacency matrix which is a 4x4 matrix. Moving ahead. So friends, here you can see that from 0 to 1 there is an edge. So by calling addEdge method we pass 0 and 1 because we want to create an edge between 0 and 1. Here we simply apply this rule that between a row and a column we just provide a 1 which represents an edge. So if you want to represent an edge between 0 and 1, so 0 will represent a row and 1 will be representing as a column. So between 0 and 1 there would be an edge which will be represented by 1. So let's see how. So as the value of u is 0 and v is 1, so here in order to represent an edge between 0 and 1, in the matrix 0, 1 we provide a value as 1. So in the matrix 0 and 1 we just provide a value of 1. So it would look something like this. So this represents an edge between 0 and 1 which is 0 row and 1 column. Moving ahead. So friend, in the second step what we do is, as this graph is undirected graph, there is no direction between the edge. Therefore we can see it something like as there is an edge between 0 and 1, and we can also see it as there is an edge between 1 to 0. So friends, this information we need to store into the matrix. So in the first step 0 to 1 we provided a value as 1. So similarly in the second step from row 1 to 0th column we'll provide a value as 1. So it would look something like this. So in an undirected graph basically an edge represents a 2 points into the adjacency matrix because if we are at vertex 0 then we can go to vertex 1 because there is an edge, and if we are at vertex 1 then we can go to vertex 0 through this edge. So therefore in the matrix this edge represents these 2 points, that from 0 to 1 there is an edge and from 1 to 0 there is an edge. Moving ahead. Now we want to add an edge between 1 and 2. So we simply pass the parameters as 1 and 2. So into the adjacency matrix, to row 1 and column 2, we need to provide a value 1 to represent an edge. So it would look something like this. Moving ahead. Now similarly, we have to provide an edge from row 2 to column 1. So we provide a value as 1. So this represents an edge between row 2 and column 1. Moving ahead. Similarly, vertex 2 and vertex 3 are connected through an edge. Therefore, in the matrix, from the row 2 and column 3, we'll provide a value as 1. Moving ahead. And similarly, from the row 3 to column 2, we'll provide a value as 1. Because if you want to traverse from third node to node 2, we know that there is an edge and that can be figured out through this matrix, that we can directly figure it out that from row 3 and column 2 is there any edge or not. So if the value is 1, we can come to know that there is an edge. Moving ahead. And the last edge is between vertex 3 and vertex 0. So it would be represented as row 3 and column 0, which is this value, will provide a value as 1. Moving ahead. And finally, from the row 0 to third column, will provide a value as 1. So friends, this is how we can represent an undirected graph into a matrix. And also one point to note that as it is an undirected graph, therefore for each edge there will be two values of 1 into the graph, which will be actually demonstrating a two-way graph. Here from 0 to 1 there is a way, and similarly from 1 to 0 there is a way. So into the matrix we represented it something like from 0 to column 1 there is an edge, and from 1 row and 0 column there is an edge. So friend, this is how we can represent a graph in the form of a two-dimensional array, which is nothing but a matrix. In my next tutorial we will actually code this algorithm into the Eclipse. I hope you like this video. Thanks, have a nice day.